We're going to sketch the graphs of two polar equations. The first one is r equals g of theta equals to 1 plus 2 times sine of theta. And the second one is r equals h of theta, which is equal to 1 minus 2 times sine of theta. We'll start with the first equation. We're going to need two results. The first is a trig identity. Sine of pi minus theta is equal to sine of theta. Now, if you don't remember this identity, we can always derive it from another trig identity, that is sine A minus B equals sine A cosine B minus sine B cosine A. So let's apply this identity to sine pi minus theta, and this is equal to sine pi times cosine of theta minus sine theta cosine pi. Now sine pi is 0, so that's 0. Cosine pi is minus 1, and so we get minus sine theta times minus 1, which is sine of theta. And the second result we'll need, we call it result B, is when the polar graph is symmetric. So we're checking for symmetry. WRT means with respect to the y-axis, which in polar terminology is the line theta equals to pi over 2. And to see that, we draw our axes. And notice that if point r theta, let's call this point r theta with polar coordinates r theta, this is r and that's theta, is on the graph, and the graph is symmetric with respect to the line theta equals pi over 2, point on the opposite side will also be on the graph. This angle also measures theta radians, and the length here is r. If we measure the angle from the line theta equals 0, or we call the polar axis, it's that angle, which is 180 degrees minus whatever the angle theta is in degrees, or pi minus theta radians. Therefore, this point will have polar coordinates r and pi minus theta. That gives us a test for symmetry with respect to line theta equals pi over 2. R equals g of theta, and when we replace theta with pi minus theta and end up with r, we found a test for symmetry with respect to line theta equals pi over 2. Now let's return to our first equation. R equal to g of theta equals 1 plus 2 times sine theta. And let's test it for symmetry. So we replace theta with pi minus theta. This is 1 plus 2 times sine of pi minus theta, but by trig identity, which we call result A, sine of pi minus theta is the same as sine of theta, and so we end up with g of theta. And therefore the graph is symmetric with respect to the y-axis, or the line theta equals pi over 2. So all we're going to need is to know what the graph looks like on one side of that line, and the other part we get by symmetry. So now let's plot some points. This is theta, this is r. We'll start in quadrant number 4 at theta equals minus pi over 2. Sine of minus pi over 2 is minus 1 times 2 would be minus 2. 1 plus minus 2 would be minus 1. At minus pi over 3, r is 1 minus square root of 3. Note that that's a negative number. At minus pi over 4, it's 1 minus square root of 2, which is also negative. At minus pi over 6, sine of minus pi over 6 is minus 1/2, and then 2 times minus 1/2 is minus 1 plus 1, that's 0. When theta is 0, r is 1. When theta is pi over 6, r is going to be 1 plus 1, which is 2. At pi over 4, r is 1 plus square root of 2. And at pi over 3, it will be 1 plus square root of 3. And finally, at pi over 2, r is going to be 3. So those are the points that we need to plot, and that will give us a very good indication of what the graph will look like. When we use symmetry, we'll get the whole graph. So I'm going to leave a lot of room here for our graph, and so give a lot of room to make the graph as exact as possible. Okay, and we need to mark these angles, and this angle here is representing minus pi over 3, and then this angle in the middle, minus pi theta equals minus pi over 4, and this angle will be minus pi over 6, and similarly we have pi over 6 and pi over 4, and over here pi over 3. So when theta is minus pi over 2, r is minus 1, that means we go in the opposite direction and have a point right here whose coordinates are rectangular coordinates is 0, 1. At minus pi over 3, the value of r is 1 minus square root of 3, which is negative. So we go in the direction across the pole, and we get a point right here. At minus pi over 4, r is 1 minus square root of 2, which is also negative. So we get a point right here. And then at minus pi over 6, the value of r is 0. So between minus pi over 4 and minus pi over 6, the graph goes to 0. It goes to the origin or the pole here, and then we have this part of the graph up here. Now, between minus pi over 6 and 0, the value of r at 0 is 1, so it ends up over here. And so between these two angles, the graph sort of does this and ends up over here at 1. And now it starts to spiral with higher and higher values now. They're getting to be larger and they're positive. So at pi over 4, we're at 1 plus square root of 2. At pi over 3, 1 plus square root of 3. And finally at pi over 2, the value is 3. And so this is the graph of one side of the graph. And to get the other side, we use the fact that it is symmetric with respect to the y-axis, or the line theta equals to pi over 2. So we get this inner loop here, and then we get the rest of it, the outer loop, on this side. And so the graph looks something like that. This is an example. The graph is called a limacon, and this is an example of a limacon with an inner loop. Now, we could have obtained this graph in another way. Let me show you how to do that. In the video prior to this, we graphed r equals f of theta equal to 1 plus 2 times cosine of theta. This was also a limacon with an inner loop, and its graph looked like this. So this limacon with an inner loop, but it looked like this. Now, one of the other rules of graphing polar equations, if we know the graph of f of theta, then the graph of f of theta minus alpha is obtained from the graph of f of theta by rotating the graph of f of theta in the counterclockwise direction by alpha radians. And so let's take a look at f of theta equal to 1 plus 2 cosine of theta, and let alpha equal to pi over 2, or 90 degrees. So what does f of theta minus pi over 2 look like? Well, this is 1 plus 2 times cosine of theta minus pi over 2. And this is equal to 1 plus 2 times, we'll apply the trig identity. It is cosine of theta, cosine of pi over 2, plus sine of theta, sine of pi over 2. Well, cosine of pi over 2 is 0. So this drops off, that's 0. Sine of pi over 2 is 1, and this is equal to 1 plus 2 times sine of theta, which is our g of theta. So another way we could obtain the graph of 1 plus 2 sine of theta is to take the graph we already know, that is the graph of the limacon r equals to 1 plus 2 cosine of theta, and rotated 90 degrees in the counterclockwise direction, and that will result in the graph of the current limacon. So this is theta equals 0, theta equals pi over 2. If we take the limacon on the left and rotate it 90 degrees in the counterclockwise direction, we end up with the limacon that we just got by using symmetry. This is r equals to 1 plus 2 sine of theta. Now let's go to our second polar equation and graph it. We'll use this principle. We now want to graph h of theta equals 1 minus 2 sine of theta. But see, we have this graph, and let alpha now equal to pi. So let's look at in g of theta is 1 plus 2 sine theta. So let's look at g of theta minus pi. That's 1 plus 2 times sine of theta minus pi. And let's use again trig identity. This is 1 plus 2 times, and the trig identity here is sine theta cosine pi minus sine pi cosine of theta. And so sine pi is 0, so this part drops off. Cosine pi is minus 1, and this happens to equal to 1 minus 2 sine of theta, which is our h of theta. So in other words, we obtain the graph right here of this polar equation by rotating this graph pi radians in the counterclockwise direction. And so that would be easy to do. We can just finish that off and have the graph of that limacon. The limacon r equals 1 minus 2 times sine of theta looks like this. And here is its inner loop. For more videos, visit www.mathprepvideos.com.